Hi, and welcome to the Populations and Resources Unit Launch video. My name is Kelly, and I am a 7th grade science teacher in Los Angeles, California. Here's a picture of me in front of some moon jellies. I am so excited to share this video with you and to talk through all of the awesome things you and your students will be doing this unit. The big unit question that drives us is, why do populations change in size in an ecosystem? The grounding phenomena for this unit is what caused the size of the moon jelly population in the Glacier Sea to increase. You're probably asking yourself, why does this unit matter? Populations and resources matter because ecosystems are complex systems. Determining what might have caused a change in the size of a population is not a straightforward question, but it's an important one as population sizes are changing more and more due to human activities. Before we begin diving into this unit, make sure you have read and annotated the unit overview, unit at a glance, and the standards, read and annotated the science background knowledge, and printed out the unit internalization guide and have a pencil ready to fill it out. Now we are going to start diving into what students are going to do and learn each chapter of this unit. The Chapter 1 question is, what caused the size of the moon jelly population in the Glacier Sea to increase? In this chapter, students will watch a video to learn about the ecologist studying the jelly population increase. They will explore the populations and resources sim, and they will get to the key concept that within a population, organisms are always being born and dying. Students will then do a hands-on model using tokens to explore how births and deaths can change a population size. Through this activity, they will learn that if births and deaths are equal, a population will stay stable. If there are more births than deaths, then the population will increase. And if there are fewer births than deaths, then the population will decrease. They will then learn how ecologists use samples to gather data of a population and how it is changing. Students will then evaluate the strength of moon jelly population data based on the evidence criterion that samples that represent as much of a whole as possible provide stronger evidence. All of this hard work leads students to Progress Build 1, where students learn that there are always births and deaths occurring in a population. Changes in the number of births and deaths can change the size of a population. One way to assess if students have mastered this Progress Build is through Chapter 1 Focus Task. Students will create a model to show the relationship between births and deaths within the population, when it is stable and when it is increasing, and then describe that in the written response. Why don't you take a second to try out this task before we look at the rubric and the exemplar. An exemplar model will show the same number of births and deaths in the stable population, and for the increasing population model, you can show either more births than deaths or fewer births than deaths, and the written response will also explain that relationship. That leads us to the Chapter 2 question, which is what could have caused the births to increase or the deaths to decrease in the moon jelly population. Students start off the chapter by reading the Reproduction and Energy article set. They then do a hands-on investigation where they add different amounts of sugar to yeast and water to see the effect that more energy, or sugar, has on the growth of the population of yeast. This leads to two key concepts. The first being that organisms in a consumer population get energy storage molecules from eating organisms in the resource population, and that the more energy storage molecules available to the population, the more the organisms in that population can reproduce. Students then go back to the sim to explore this further. This is a great opportunity to really focus on how to pull evidence from a graph. They then explain their understanding in writing while looking at other populations, and at this point they should be able to explain the key concept that the larger the consumer population, the more energy storage molecules it will need. Therefore, it will eat more, causing more deaths in the resource population. All of this learning prepares students for Progress Build 2, where they understand that a change in the number of births and deaths in a population can be caused by a change in the size of its resource population or consumer populations. One way to assess if students have met Progress Build 2 is through the Chapter 2 Focus Task, where students need to create a model of how two factors could lead to an increase in the jelly population. They're modeling how an increase in the zooplankton, the jelly's resource population, and a decrease in the leatherback turtle population, the jelly's consumer population, could impact the jellies. They then explain which of these factors they think caused the increase in the jellies. Why don't you take a second to pause and try out this task before we look at the exemplar and the rubric. Now let's look at the exemplar models. Model 1 should show the same number of births and deaths in the stable population, and then more births than deaths in the zooplankton population, leading to more energy storage molecules available and an increase in births in the jelly population. Model number 2 should show, again, the same number of births and deaths in the stable population, and then more deaths than births in the turtle population, meaning that they need less energy storage molecules, leading to less deaths in the jelly population. The written response will then explain which of these factors students believe is most likely based on the evidence. At this point, students are ready for Chapter 3, where they will answer the question of how could a population besides the zooplankton or the sea turtles have caused the moon jelly population to increase. In this chapter, students start off by reading about another real-life jelly population affected by competition. They will explore how competition can affect a population by using the 6 population mode in the sim, which leads them to the key concept that 2 populations can compete for the same resource population, and that the change in one of these populations can affect the size of another population. They then analyze more evidence to see which other populations besides the jellies, resource, and consumer population could affect the jellies. At this point, they then focus on the algae, the wall-eyed pollock, and the orcas. Through all of this learning, students have reached Progress Build 3, where they understand that a change in the size of the births and deaths in a population can be caused by a change in the size of a population other than its resource or consumer population. A way to assess if students have met this standard is through the Chapter 3 focus task, where students will put together everything they've learned to write a CER to explain what they think caused the jelly population to increase. Pause and take a second to look it over and complete this task. You can see the rubric for this task. In the exemplar, students should be explaining how Evidence card A supports claim 1, an increase in algae causes the zooplankton to increase, which causes the jelly to increase, or how evidence card B supports claim 2. A decrease in the wall-eyed pollock population will lead to an increase in the zooplankton population, which will lead to an increase in the jelly population. At this point, students have learned all of the new content and they're now ready to apply it to another question. The Chapter 4 question is, what is the main cause of the decrease in the size of the orange-bellied parrot population? In this chapter, students will learn about the orange-bellied parrot. They will create a food web for the orange-bellied parrot ecosystem. They will analyze evidence to see how the organism's population sizes have changed, and they will participate in a science seminar to discuss what caused the decrease in the parrot population. One way to assess if students are able to apply their learning through another question is with the Chapter 4 focus task, where students will write a CER about why they think the population decreased. Pause for a second to complete this chapter focus task. Looking at the rubric, you can see that we want students to show mastery of all 3 progress builds. The exemplar should show mastery of all 3 progress builds using evidence and reasoning to support the claim. At the end of the unit, students will take the end of unit assessment, which will assess student mastery. Let's do a few practice questions to get a better idea of what that assessment looks like. Let's look at question number 1. A population of panthers lives in the southeastern United States. Over 50 years, the size of the panther population in the region has increased. What best explains the increase in the size of the panther population? Pause and choose the best answer. The correct answer is C. More panthers were born than died. This question assesses Progress Build 1, that there are always births and deaths occurring in a population, that changes in the number of births and deaths can change the size of a population. Let's look at question number 2. Scientists have been studying the size of 3 populations along the coast of Antarctica. In this ecosystem, penguins eat sardines, a type of small fish, and sardines eat zooplankton, very small animals that live in water. The data showed that all 3 populations were stable. Then the penguin population decreased suddenly. What will likely happen to the size of the sardine population as a result? The size of the sardine population will... Pause and take a second to answer this question. The correct answer is D. Increase. The smaller penguin population will need fewer energy storage molecules, so they will eat fewer sardines. This will lead to fewer deaths than births in the sardine population. This question assesses progress build 2. A change in the number of births and deaths in a population can be caused by a change in the size of its resource population or consumer populations. Let's look at one more multiple choice question and question number 3. In a mountain lion region, tigers eat wild pigs and wild pigs eat worms. In the last 5 years, the sizes of the populations have been stable, but recently the tiger population has increased. What will likely happen to the worm population? The worm population will... Pause and take a second to answer this question before we look at the answer. And the correct answer is A. Increase. The larger tiger population will lead to fewer wild pigs. The smaller wild pig population will need fewer energy storage molecules to reproduce, so they will eat fewer worms. This will lead to more births and deaths in the worm population. This question assesses progress build 3. A change in the number of births and deaths in a population can be caused by a change in the size of a population other than its resource or consumer population. Let's look at one of the short response questions to get an idea of what students need to be able to show on those. Written response question number 1. Scientists have been studying 4 populations in the ocean near Alaska. In the ocean, sharks eat sea otters, and both sea otters and sea stars eat clams, a type of shellfish. The data shows that recently the shark population increased. How will the increase in the shark population affect the other populations? Be sure to explain whether the sea otter population, the sea star population, and the clam population will change and why. Take a second to write out a response to this question. A level 3 response for this question will have births greater than deaths in the shark population, that the larger shark population needs more energy storage molecules leading to a decrease in the population of sea otters, and that as an indirect effect, less sea otters means that there will be an increase in the clam population. Hopefully, you now feel super ready to teach and lead this unit. Thank you for all of your hard work. Make sure you consider these final steps if you are a KIPP teacher. Thank you and have a great day.